Guten Abend, welcome zu meinem Video. Wir begrüßen Sie in der Frühlingsmonat in Deutschland. Heute lernen wie man Key baut und dann die trainiert Key in der REST API zum Testen einsetzt. So beginnen wir auch mit diesem Video auf Englisch, damit auf Englisch User verstehen können. So very good afternoon to everybody. Welcome to another video. So in this video we are going to work with like AI. Today the agenda is different. We are not going to work with any microcontroller, neither in ESP32 nor in any another microcontroller or MCU. So in this video I will teach you like how we can build an AI model, and then we can like deploy them in anywhere, like in like if you want to test them, then we will test in that REST API, and I will show you like that how this building an API model work. And then let's see. So we are going to build this thing in like from the scratch, and at the last of the video we'll be in the like full position, and then we can see that how these things work in real world. So before we start, like I will give you the brief introduction, like how we are gonna build this AI model. So today we are going to explore like how the computer can learn themselves by so-called neural network. And imagine like have a brain, and like it takes information from our data. So like they're like in neural networks, they are like layers called neurons. So these neurons work together to figure out the patterns. So in neural network we have a three layers, especially these are called like input layers. The second will be like hidden layers, and third will be the output layers. So in input layer, suppose like if you're giving some data, that data will be processed with a hidden layer, and then the final layer, the output layer, it will give you the final outcome from that this data. So today we are going to work with that. So today we will build something related to electronics also. Like in this video we will I have some collected data. So like I collected some data from my DHT sensor. This is a DHT11 sensor. It measures humidity and temperature. So I have collected a lot of data for like thousands of samples of this data, and like and I shuffle that data. Like I will show you here in my computer. Like I will show you. Look, so these are the data which I collected. So like I have classified these things in like four condition: extreme, pre-failure, and need attention, and the normal condition. So like suppose if the temperature is like, these are temperature. So suppose if the temperature is 50, humidity is 26, in that case the condition is considered as normal. Here if the temperature exceed 99 and the condition like have like humidity of 88.7, and in that case it is considered as extreme. So I have labeled these condition or temperature on four classification called normal, extreme, pre-failure, need attention. So in this video we will upload this data. It is like a bunch of data, and once we will like put this data into our AI model, the AI model, we will train that AI model to understand the patterns, and after understanding these patterns, the trained model will like can predict the outcome depend on the temperature and humidity. So like suppose uh, if you're working in an industry, and industry have some certain type of motor, like big motors, and like for years it has been worked, so the data have been collected, so they have monitored that in this condition the data got like the machine seems failure, in this condition the machine is working normally. So similarly we have also collected the data, and based on the performance and based on the working of that motor, we can predict the failure of that machine before failure happens. So this is like today's our topic. So like let's start, and like I will show you that how we can build an AI model, and we will deploy and we will test that how this AI is working. So it is like AI based predictive maintenance for any machine, not any machine, the machine for which we have the particular data. So let's start, because everything is going to work with the data. So as I show you already, like in documents, like this is our data, okay, and data is saved in .csv form. Like we have like thousands of samples we have collected, and then we have shuffled the data. Shuffle in the sense like if you go and like have this normal condition continuously, in that case our model will start showing biased results. So in order to remove the consequences that our model should not behave biased or not learn any particular pattern, so I have shuffled the data. So that's why it's like different. Somewhere it's normal, extreme, pre-failure, and need attention. So let's start. So for this, the tool which we are going to use in this like is TensorFlow. The coding language is Python, and then we will like use the Flask to deploy this AI model on web server. It will be live, and then we will test using the REST API, and we will see that yes, whether this model is working or not. The better thing is that like in this we are not going to write any particular code. Here in this, like the model is going to understand the data, and it will understand the pattern, and on the behalf of that pattern it is going to show you that outcomes. So how, like suppose like it will be very interesting. So let's start. So I will start with Ubuntu. This is our framework where we used to work, where we are working all the time. Okay, so in this, like first we have a pre-built library already, so I already created. It's predictive maintenance underscore new dot we have already, and I have transferred this data, refined synthetic data.csv, already from our window machine to our WSL subsystem for Linux. So let's start. So our first agenda is like to build or like to write a code. So I will write a code, and I will like first I will write the code, and then I will explain that like what line explain and what line is doing, what is the use of that particular line. So let's start. So for start, like nano. So now we have done two things. First, I have written a code named train_model.py. This is the main code which is used to train this AI model. So in this AI model, how like we have trained this AI model, I will like open this code again, and then I will explain you like what are the important things to be keep in mind whenever you are working with or like developing an AI model anywhere. Like so, I will open it and like I will show you here. Okay, I will increase the screen, and then I will explain you like what are these things and where these things are used. Okay, so first thing I think I already show you in the beginning of this video, this refine underscore synthetic data.csv. This is our .csv file which is uploaded in this code so that the model will like go with this .csv file, and it will learn the patterns, and it will learn this classification and how the things are working with different timestamps. So okay, so let us start with other things also. So these are things like numpy as job, like these are like similar like in when you do the C coding or C++, like you used to like use this include stereo.h and all this thing conio.h, so like that. So as I told you, like this is the data which we used, dataset file, and then here I have written this print df.head. Okay, so this is like display the first rows of the data frame to inspect the data. Okay, and then we have used this df is equal to df.drop owner. So here I think I have done one mistake, so just let it clear first. Yeah, so like this is used like to clean the data by removing the missing values, and then like you can see this like features I can this features like temperature and humidity, and then we have labeled them, and then when we have started to encode the label using the label encoder. So that's why we have using this label encoder here. So here in this, first if you see y underscore encoded is equal to le.fit underscore transform. So like the use of this is like to transform label into numerical format so that our model will understand. Okay, and then what next I can tell you, this like normal is like it's like save the model encoder classes from this like you can save it for later use, you can modify and you can do, that's why I use this. And then xtrain xtest, these thing like for like here in this like 20% of the data is used for like if I have 1000 samples, so in 1000 samples 200 will be used for the testing, and rest 800 of the data will be used for like how to say uh, for training of this AI model. So this is done, and then where we can go, and I can tell you another thing. Let's see. I think the most important will be here, building this neural network. So first see this. This is the main thing which we are building. This is the main thing. So this is our neural network model. We have used the Keras sequential API. So that's why I have written this model sequential. And then this is the input layer, which I told you in the beginning of this video. So this is the our input layer with 16 neurons. So this is our 16 neurons in input layer, and then this is our hidden layer, the second layer, having 32 neurons, and this is our third layer, and like this is called like output layer. So these all layers like 62 16 32, these all layers are like connected with each other, like for like following the feed forward neural networking. So the data can be exchanged, can go bypass, and like they can like these are like interconnected like neural, like as a human body. So this is done, and then where we can go, I can tell you like this compile modeling with I have used this adam optimizer for like an sparse categorial for the like cross entropy loss. And what I can tell you, then let's go here. So this is like our history, like we are like train the model on the training data. So this is the data which we used, and like here it's epoch is equal to 30, and validation to validate the model on the test data. And then we are saving our model like train underscore model dot keras. Okay, so this will like save our model into a file, and then we have used some graphics. So like suppose if we are making any AI model, so in that case we have to put some graphs so that we can understand what how our data has learned the thing. So that's why we use. So I think this is not that important. So this is our train model.py. Let's come outside of this. Okay, uh, and then we are gonna use I will show you this API. Okay, so I will explain you what is this. this is not that important, but it is used for like testing. Like suppose I have written this code, this train model.py. When I will compile, it will be ready, but where we can see this? So that's why I'm using this API, REST API, using Flask. So we can like test and debug, because testing and debugging is much important as like training our model. So I will explain you what is this. So for this, like from where we can start, like yes, like as similar like C, we use some libraries. Okay, and before like starting what is Flask, I will again explain you, like Flask is a lightweight Python web framework. So like it will help us to explore our train model, like as I told you, REST API. And it means like we can send our HTTPS request. I will show you where, like, you can see here, app.route predict this name. So this is our API. Like it will like divided the things in like temperature and humidity values, and the API will respond with the prediction from the model. Like this allow us to interact with the model easily, and it is like it is very essential. Like if we deploy our machine learning model into a production, so definitely it's going to use. So so let's see, like after we have done this, let me check like is there any issue in the code or not. Okay. Mm, so right. So before we start like this running, or like before we compile, uh, one thing keep in mind, like if you're like training any data, you have to be like very clear. Like you are, whenever you're writing a Python code, the pattern should be like correct. Like if you have, like if you write a C code, in that case the code will compile easily, but doesn't matter like how you have written. But in like writing the Python code, your like code must be in a proper sequence and alignment, then only it will be running or it will compile. So can I will start this predictive main. So our nano dot this train model.py. So we are gonna compile this and we will see that how the things are gonna work. So Python tra train, the name of our model.py. Let's compile and see the result. So you can see the compilation. Epoch is 30. I will tell you what is epoch 30, or like epoch. Yes. So now our model has been compiled successfully. So what I told you, epoch. So in the code I already show you that epoch is equal to 30. What does it mean? It means like suppose I will give you a live example. Suppose if you are going to take an exam, and before going in any exam, you read a book single time, only one time, and then you went and you wrote the exam. In that case, your efficiency, like your performance, will be like, if there is a test out of 10, in that case you will get like 5-6 marks. It's my capability. If I will read any book only one time, definitely I will get 5 or 6 marks, not more than that. But if I will read that same book 30 times, or not 30 times, if I will say that I will read that same book or the main topics like 2 times, 3 times, 4 times, 5 times, definitely my efficiency will get increased as compared to the previous one. So if I will read only single time that single book, in that case I can perform only like 50% of total. And if I will read that book, definitely the performance will get increased, and I can perform like I can get marks 10 out of 10, maybe 9. So similar goes to this neural networking on in this AI model, this machine learning model. So look, I will show you this. In the first epoch, the accuracy, look the accuracy, it was 50%. As the number of like training or number of times this model went to that .csv file, the efficiency has been increased. Second time 84%, third time 89%, then 91%, 92%, 94, and it is going go, and then if you can say it's 99%, it's the efficiency. Okay, so look, as I told you in our data, there were 4 conditions: extreme, pre-failure, need ascension, extreme, extreme. Okay, so this is the timestamps. These are the data. Okay, how it has been classified. Now, because we have everything, and we have this, when I have written this code, we have this, we save some data, like the canvas or the figure, which we can see and understand that how our model have worked. So I have the model already. I will show you here. Look, you can see the model accuracy. The red one is the training accuracy, and this blue one is the validation accuracy. So you can see as the number of epochs increases, you can see the epochs during this starting like 5, it was not completely aligned with each other. In 10 also it was not completely aligned, but as the number of epochs increases at 15, like the alignment, it went simultaneously. So what does it mean? What is validation accuracy? What is this? So it means like the data hasn't been seen by the model. Once the model is being like it's going, and in that case it see that like it understand the patterns and understand the temperature, how the things are working. So during the training you can see this alignment. So it means that like model accuracy, like how the model has learned the things. So as I told you, during the compilation it went 99%. So you can see that it has been like aligned and it shows the accuracy. Okay, similarly this model loss over epochs, similarly the things like loss over the thing and the number of epochs, the epochs are 30. Okay, so this is how our model learned the things pretty so far. So now we wrote the code like app.py, which I already told you is a Python framework which is used for taking our AI or machine learning model on a web server, and we can like predict, or we can like test our machine learning, or we can test our AI model on a web server. So it's like a deployment API, REST API testing thing. So I will run this also. Okay, so for this Python app.py, and we will let me increase the size. Okay, there are some warnings, but it's not related to us. Look, now it has been successfully deployed. Now it is available on web server. We can use various application also to test our this AI model. So like if you go with this http 172.24.224 and something like this, and just copy this, let's go to Chrome. It's showing the requested URL not found. I think I did something mistake. Maybe I will just, yes, here we have to write predict. Okay, you can see here also the differences, errors. Okay, error 404, error 405. Okay, but whenever, like suppose if I will give F5, you can see here the request has been like posted and like it shows there is some error. So it's not error with our model. It's not error with our model which we train in AI. It is like this Flask API. This, it's showing that this method is not allowed. So for in order to overcome this, we are just going to use this Postman API. I have this. Okay, remove this, and we will copy our new URL, something. I will small this one. Okay, and we have to monitor here also. We will monitor all the things. Okay, I will show you. Just copy this, and here you have to do this predict, because it has been declared in our Flask API predict. Okay, let's say yes, you can see how cool it is. Look, now it is giving the prediction based on our machine learning model. So look, it's taking some time, like some 106 milliseconds and steps, and these are being given by our our AI model. Means like if we are giving some data here, it's being redirected to our machine learning model, the AI model. The AI model just read this, like what is this, and then it will give its own prediction based on that our CSV, so-called CSV file. So let's make something fun here. Let's change the temperature, like it's 95 degrees. Okay, and let's send to our model, and the model will predict and give his prediction. So just send. Oh, it's a pre-failure. You can see here also the model read the data, like what is the input, and it's giving its output. It's pre-failure. Similar, let's change here. 50, humidity is 50, but the temperature is only 55 degree. Maybe let's see. It's a normal condition. Let's give 25. Normal. It's still normal. Let's increase the humidity. Let's go to 90. Humidity is very high. 90. Maybe that model will not work. Maybe it's an extreme condition. Let's go to 100. extreme condition. Okay, let's go to 25 for this, and for this let's go to 100. It's a pre-failure condition. 95. Oh, extreme condition. So look how our AI model is responding, how beautifully it's responding and it's giving it accurate results based on our data. So this is the way I like deployed on REST API for the testing and debugging. Now what the other thing which we can enhance for this, like suppose this like training is successful, the deployment or the testing is also successful, it's giving a 100% not 100% but like, yeah, 99% I will say correct predictions. Extreme, let's see one more time. Yeah, so it's giving good prediction. So what else we can do? We have two way. Suppose like you just connect your microcontrollers and then just collect the temperature from your sensor, and then it will like send here, like it will send to this model, and then it will predict that whether the temperature is very high or temperature is low, and then it will like predict. And if you want to go like more than this, in that case we can simply deploy that AI model inside our microcontroller, and in that case the model doesn't require to go on any web server or anywhere, and then it will like simply give its prediction, and it will like give some alarm, something like that. So for that, like suppose if you want to deploy that AI model on any microcontroller, in that case you have to use for me, I use like TensorFlow for training this AI model. For deployment on any microcontroller, because microcontrollers have this limited memory, so we need to understand the memory manipulation. Without having this memory manipulation understanding, we cannot deploy any AI model because it have a limited storage. So we use TensorFlow Lite. It reduces the size, and then in that case, like we can deploy and we can have this neural network inside our ESP32 or any microcontroller, later version of Raspberry Pi, and yeah, so on, pretty so far. And what else I can say? This neural network. So neural network is like same as like our human neural network or something, like it's a brain in our brain, something like it's like an artificial brain which is like working, and it's giving its own prediction. We can use this for any particular like how I can say this, motors, like for which the particular data is trained. We cannot use this particular refined.csv to any motors. Like suppose if you go on a big industry, in that case the starting temperature is 100 degrees Celsius, and like a pre-failure condition is like 600 degree, not like, maybe it's I'm just giving an assumption, it's not like that. So in that case, for that we have to get the data from that particular motor, not from any other motor. So everything like have their own data, so for particular thing we need that particular data. So this was done. One more thing I will show you. Let's show you. So right now I will connect my ESP32 microcontroller to my computer. I have a Arduino code with me, and like we will connect our this sensor also, DHT sensor, and then we will like uh, give some we will do the simulation. We will increase the temperature. I will use my hair dryer to increase the temperature, and then temperature will like it will read the readings from our this hair dryer, and it will just give the. So guys, now I have connected my ESP32 with this DHT11 sensor. So now I will show you that how this data will be like collected from this sensor, and it will send the data like temperature and humidity to our trained model, and the model will give the prediction on basis of this temperature. For this, I will use my hair dryer. The hair dryer will give the it will like simulate the hypothetical condition. I can increase the temperature, and when the temperature will get increased, it will the model will read the readings, and it will give that like whether this condition is like normal, extreme, pre-failure, or whatever it is. So let's start. So as I told you, again I will open, because there was some error, so I just fixed it now, so it's working. Okay, so just run it, this python app.py. Okay, it has given this some particular link for this, because this data is available on this web server. So in that case, how this will connect, or how they will connect, and then they will interact with each other, the sensor and the model, the trained AI model. So in that case, I'm using local tunnel. So for this, I will show you how the command will work. LT port and 5000 as in our Flask dot this ap.py code. So just it will give some like this. Just copy this, copy, and I have already written a code on in Arduino IDE. So we will just simulate it simply here. So let's remove the serial monitor. Look, this is my code. So for this I need to remove this here. Collected here, just write predict because it has been already declared in our Flask API so called. This is the name of my password and the on my Wi-Fi, this my mobile Wi-Fi. So just let's compile this. You can see here the GPIO, the pin is connected with 2 GPIO, 2 is connected with this DHT11. The positive will be connected to 3.3 volt on this our ESP32. The negative will be connected to ground because we cannot float anything. So because in that case the proper communication between the sensor to the microcontroller will not happen and we cannot read anything. So that's why. Let's see. So I will open this here, and you have to keep in mind this thing, it's only run for some particular period of time, so you have to monitor all this thing like whether it's expired or it's still working. This is the model again here, and we'll see it's taking some time but it will compile soon. And then let's see the prediction. So now it has been connected. I will here you can see here also like it has been successfully connected and one prediction already been done. So let's see on our serial monitor. Look, it's already started. Open the serial monitor, large it, and like look, humidity 10. This is a normal room temperature. It's just reading the room temperature. Okay, and you can see here also. So I will make camera here. I will be here. Sorry, I will be here. It will be here, and we will see everything. Okay. Oh, sorry. Okay, so let's simulate the condition. So I have this hair dryer, and I will increase the temperature, and let's see. The temperature will increase. And guys, you have to monitor because we have condition for certain. So let's see, temperature is now 52 degree, humidity is 10. Still it's showing the prediction normal. You can see here normal, but it's still look, you can see this model, this AI, sorry, and it is giving its prediction. The prediction level is extreme. The situation is extreme because we have just simulated the temperature for 60 degree. So let's you can see the temperature is rising. Right now we have the temperature of 70 degrees Celsius. Look, now you can see it. Now when the temperature rose to 84 degrees Celsius, the prediction from our AI model is like pre-failure condition. So it's saying that the temperature is abnormal. You have to stop your this device, or you have to go and see that what is the problem. Look, now it's 79. Need attention. The reason for need attention is like during the training of our AI model, like when I was collecting the data, I gave that like when the temperature will rise suddenly, like in 10 seconds for like 3 degree or 4 degrees, it will spike as like need attention. That's what it's showing attention. Then again extreme. Let's compile one more time. So yes guys, this was the video all about. So today we have successfully trained an AI model. We have also called an AI model from scratch. We deployed and we tested on our Postman API, and then we have deployed or we have used a microcontroller to collect the data, like real data like temperature, and we simulated from our hair dryer, and then we see on our serial monitor, and it's giving the prediction. The model is here, you can see here this model is giving the prediction within a gap of 2 seconds, I think. And once like it's sending the data to our model, the model is giving the prediction. So this is so called, we can say, AI based predictive maintenance or predictive models. So this is, yeah, this is all about from today video. I hope you will like this, and if you want more interesting thing, if you want to learn computer vision and anything, stay tuned with my videos, and definitely I will show you everything. So thank you so much guys, thank you for watching for this video, thank you so much.